My name is Karine Anselme, and I'm a senior researcher in the Institute of Material Science in Mulhouse in France. And my research focuses on the interaction of cells with surfaces of materials, and more specifically the response of cells to topography and microtopography, so at the cell size. Actually, I obtained my first postdoc position in an orthopedic hospital, and the interest was there to develop, to optimize implant for hip prosthesis, and we had contact with engineering school where they were able to control the topography and especially the roughness of the implant, of titanium implants. And so we decided to have a look in vitro with cells to screen the different topographies.
So the deformation of the nucleus, that information, how would you apply that? Is it to look at cancer cells, or would it be looking at differentiation of stem cells?
At the beginning, it was to look at the differentiation of the behavior of bone cells on these different pillars. But actually by random, because I have difficulties at this time in Mulhouse to have access to mesenchymal stem cells to prepare these bone cells, I decided to buy a cell line which is well known in the field of the orthopedics to evaluate the response of bone cells to implants, which actually the SAUS2 cell lines, which is derived from bone cancer. And we had the surprise to observe the very strange behavior, which is actually a total deformation of the cells between pillars and the deformation of the nucleus, which is more surprising because nucleus normally is stiff and should not be able to deform so much. And so because of that, we published these results, and now we are working with other cancer cells derived from colon, from different origin, to see if it can be a universal behavior of cancer cells. And it seems that it's the case.
Okay. Different stiffnesses, there's different cytoskeletal properties like rearrangement in lamin and also intermediate filaments.
Yeah.
Have you considered altering the stiffness of your microtopographies to see if that changes the deformation potential?
Actually, we tried, but the method we use to prepare the microtopography is by replication. If you want to replicate something which is soft, you will deform it. So it's actually impossible to make something soft by these methods. So it should be interesting, but we have to find another way to prepare soft pillars. So it exists. It's used actually as a tool to evaluate the mechanical properties of cells, but it's a different approach. If the cells can deform the pillars, they will not be able to deform themselves because the pillars are too soft. So it's slightly tricky, and we have to think more about that to be able to measure the response of cells on soft pillars.